I think there are a set of words, a set of topics associated with each one of them. They're not necessarily the same. There is so each one of them is a fairly large area. So for example, in data science, somebody said statistics and so on, but somebody also talked about interpretation and so on and so forth, right? So if you look at data science itself, it goes from actual, and if you look at the words that all of you use, it goes from actual theory to very practical applications. And depending on where each one's mindset is, you saw a set of words. Somebody said statistics, somebody said mathematical modeling, things like that. Then somebody said business, interpretation, decision, so on and so forth. Same thing with big data. Somebody talked about distributed file system, which is actually the core of the engineering aspects of it. Others talked about collecting the data, the value, velocity, things of that nature, right? So, and final one, customer experience, and we'll get started. Customer experience.
Profitability.
Okay.
Value.
Okay, value to the customer. Okay.
Ease of use.
Ease of use, okay. Great.
So when it comes to data, we always think of a computer and something which is a person sitting in front of a computer.
Got it.
But I think what I look in the future is all this data science, big data, still yet to understand in terms of it, but this is somehow going to give the customer
Exactly.
seamless experience in the future.
Absolutely.
And it's just there when he needs it.
Absolutely. So all of these, yeah, customization. Yeah,
Behavior.
personalization.
Customer behavior.
Absolutely.
Behavior, customer behavior, understanding customer behavior.
Yeah. All again, same thing.
It's
Right?
about building trust with the customer.
Yep. Absolutely. No, I would absolutely. However, it can have both sides, right? It's also the thing that would build trust with the consumer is the thing that the consumer is most scared about as well. Is the confluence of these things and what it does to customer experience, right? The same thing that company A does may seem a great experience to you, but company B does it seems creepy to you, right? So you're okay if Google makes a recommendation in Gmail, which is basically after parsing through your entire mail history, but if there were a third-party small abc.com parsing your email, you would have a problem with that, right? So that's the other piece, right? That's trust, going back to trust, right? You trust Google, you don't trust, for whatever reason. I'm not passing a judgment whether you should trust Google or not trust. I'm not passing a judgment about any company, including mine. The only reason I'm talking a little bit about my company is so that you get a context of what we do. That's all. So because this is sort of an environment where I want us to sort of discuss things, ask questions. So this basically gives you some sort of an idea of what we do. Basically, think about this. Forget about the big data and all that, right? Consumers, look at the top, right? Consumers are interfacing with companies through a screen or a speech environment, for the most part. Like literally, if you look at how consumers interact with companies, it's either through a phone or through a website or through chat or through sort of talking to a speech system or whatever, right? So as they interface with the company, our products and services are trying to be that first interface wherever our sort of consumers hit our clients. So just to talk a little bit about our clients, we have a bunch of clients in 4 different verticals, 4 or 5 different verticals. Telco, banks, retail, travel, and technology. Okay, 5 different verticals, and our clients are literally maybe 3 or 4 of the top 10 banks in the world, 3 or 4 of the top 10 telcos, 5 or 6 of the top 10 retailers in the world, and so on and so forth. So these are large companies, typically Fortune 100, Fortune 200, Fortune 500 kind of companies. Yeah. So, and our sort of basic product stack is the following. Consumers are hitting these companies through multiple sort of ways they are interfacing with the company, right? It could be they're calling the call center, they could be going to their website, so on and so forth. In each one of these cases, we have a product that actually drives them to resolve the problem as quickly as possible through self-service means. If they are not able to solve the problem through the self-service means, then it goes to our assisted platform, which is like our own chat platform, our own sort of voice platform where you have our agents in the back end as well. The world of customer care, consumers are saying they will touch the company in whatever way they want, wherever they want. One day they'll be in the tablet, another day they'll be in the laptop, third day they'll make a call, fourth day they may do something, they may just go to the brick and mortar store, whatever it is, right? At the end of the day, for them, they will do whatever is convenient to them. It's the company's job to stitch all of this together to give the kind of experience that's seamless, that does not lose context as people go, right? One of the most irritating things is you went to a company's webpage, tried to fill in a form, the website crashed, something happened, you were not able to fill a form, now you call the call center and the whole story starts again. Or you come back to the website one day later, the whole story starts again. None of these need to happen if you are able to persist context through the journey. That's the essential goal, right? And this is the product stack, right? I was told this is more of a product leadership, product management sort of group. So the focus of this talk is building data science driven products. That's the focus of the talk. Hopefully that's something that will resonate with you. This is essentially our product stack. At the top, what the consumers, what our clients see is the solutions. Right? They don't care about anything else. And our solutions are outcome driven. That's one way we are disrupting our competition, right? So take predictive sales, right? One of our predictive sales solution is our chat platform, where and I'll give you a small demo, right? Where you are doing predictive targeting, identifying who are the people who are going to incrementally buy through chat, where we are going to actually precisely determine who's deriving incremental value through chat and target only those people for a chat interaction and create incremental revenue. And our business model is simple. We don't charge for the platform, we don't charge for the agents, we don't charge for anything. We just charge a bounty. So if I make you $100 million, I charge you 6.5% of that, 6% of that, 5% of that, whatever, depending on the business there. So it's a very simple gain share model. Similarly in service, you just say what you want. You don't say, it doesn't say press 1 for account, press 2, blah, 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 not like that. It says what you want. So then you say, hey, something's wrong with my statement, and then it figures out what's wrong and presents to you a solution. So that's and we'll get into details of all of that, right? So that's and there the business model is very simple. Since you guys are all business facing people, the business model is very simple. I'm driving, let's say your current IVR is driving a 60% self-serve rate, which means 40% of the people are landing on the talking to an agent, right? If I drive it by 1%, it's worth millions of dollars to the company. Very simple reason is, we are talking about Fortune 100, Fortune 500 companies, which sort of have, in these verticals, have around anywhere between 200 to 500 million calls. So if I drive down the volume by 1%, it's worth a lot. If you can just do the math, it's $5, $6 per month. Okay, I'll stop here. Any questions? And then we'll dig deep into what we do.
So this is the last part. You said you will drive down the volume of calls that come to the...
Yeah, absolutely, because I'm solving it through self-service, right? I have an interactive voice system. So I'm going to solve the problem. Let's say now so think about it. Let me give you a simple use case, okay? And this is a fairly simple use case of what I'm talking about. It can be far more sophisticated, as you see. So think about it. So I am a client of Citibank, okay? My card got declined at a grocery store. My card got declined at a grocery store, okay? And now, 10 minutes later, I call Citibank. What's the typical response of Citibank? It says, okay, type in your account number, for for account information, press 1, for this thing, press 2, for something else, press 3. If none of these help you, press 0 to get connected to a customer care representative. That's it. And what do people do? They connect, press 0, right? And get connected to a customer care representative, right? However, Citibank knows your transaction just got declined. And more often than not, it also knows why it got declined. Very, very common use cases, it got declined because you didn't pay your minimum balance. That's why it got declined. Okay? All of this information actually exists in real time, right? So, if the interaction were the following, This doesn't even require some of the sophisticated technologies I'm talking about. Just requires leveraging data in a structured manner. So as soon as you call in, what would the interaction look like? 10 minutes. Okay, so the IVR says, hey, if you're calling about the decline transaction, that's because you have to pay $25 of minimum balance. I can process the payment right now, because that can be done automatically. So the minute the guy processes the payment, you're done, right? And you're back. So this is not a call that even needs to go to a human being. It can be solved upfront. That's what I mean.
Over the time, so you used to be mature enough to take up certain behavior of the customer. So how do you make it sure that the idea transforms such a way that takes care of the behavior?
Yeah, you'll see that's the whole talk, that's what the talk is about, basically. So if I have a new client, then the new client needs to have models that are trained on their data. So those are the guys who are doing that. And basically this, we have around 60 plus data scientists, 25% of them are PhDs, 75% of them are masters plus PhDs, around 50 plus patents by our organization. Areas of expertise are machine learning, data mining, statistics, operations research, speech recognition, natural language processing, so on and so forth. Our IP assets are in areas which are very related to what I talked about, our business. Natural language, speech recognition, omni-channel, intent prediction, which is essentially saying, how do I stitch channels together? A design of experiments, which is saying, how do I mature user experience, agent performance, text mining, social mining, so on. So now, getting to the heart of what we are going to talk about, right? Essentially, the key thing is data science and customer experience. If you look at it, how did things start 50 years back? Actually, customer experience was great 50, 60 years back for most part, right? Because you had very personalized service. This shows the local grocery store, right? Is the grocery store your parents probably went to when they were younger, and so on and so forth. And the guy knew you, they knew what they want. If you're the kid, when I was a kid, my guy used to have the exact chocolate, like there was something called Fruity. He knew I liked that, he'll give it to me. You can't get any more personalized than that, right? But the point is, what's the problem with that? It's not scalable. So the entire journey of all CRM, data science, big data, blah, 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 is to make this scalable in the context of customer experience. I'm not saying that the only job of big data and data science, but in the context of consumer experience, the purpose of all that is make this scalable to whatever level you want. That's the purpose. At the end of the day, there used to be this grocer who had 10 customers, and those 10 customers he knew everything about. They knew when the child was going to college, or what is the what kind of chocolate he likes, what college he studies in, everything. How can you make that scalable to 200 million consumers? Right? That's the problem you're trying to solve. So how did it evolve, right? So the version 1.1, I used to work for Ford. This is Ford Model T. One of the things when Henry Ford was asked, what colors can I get the Model T? He said you can get it in any color as long as it's black. And that's the key point there, right? Which is essentially saying, I don't care about you, I'm trying to build scale in manufacturing. That's the point. His point was, for me to make the biggest value I'm giving you as a consumer is I'm going to make automotive affordable to you. Don't ask me for anything more, which is what it means by saying, hey, you can have it in any color as long as it's black, right? That's the whole point, right? That's what he's trying to do, right? So this was the version 1.0 of big data and whatever, what you call data science today, right? The buzzwords keep changing. But the point is, the goal of the first generation of data scientists, analytics, whatever you call it, was driving efficiency into the system through data. Yeah? Second, version 2.0, your classic marketing analytics, CRM analytics, which was a big buzzword in the early to mid-2000s and so on and so forth. Essentially using tools like SAS, doing a lot of offline analysis, segmenting consumers. Here the goal was moving a little bit more towards that, which is saying, okay, can I target people? My market is big, but it's made up of these cells. Each cell behaves in my view, in this view, each one of these groups behaves in a completely homogeneous fashion. Which is better than that, But still, so which is essentially, if you take the car example, it's saying, okay, youths between 17 and 20 who live in California and are fluent above 150,000, their parents make $100,000 or above of income, blah, 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 they like these kind of cars. So it's segmenting it a little bit more, but still there's no personalization. To the world of big data, this is the world we are in today, right? Where you leverage every signal. As consumers have a touch point with you, you incorporate that and at scale in real time are able to incorporate that to make the next decision, right? So the key things there, you talk about, I know, volume, velocity, variety, blah, 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 veracity, whatever it is. But the reality is two things. Ability to deal with all kinds of data, the variety piece at massive scale, but the most important piece is what do each one of these mean? What does volume mean? Volume obviously is the easiest word, it means a lot of scale. What does variety mean? The variety means can I stitch a set of attributes, so each intent has a different set of attributes, each consumer has different set of touch points, right? Can I stitch all that together? And the last piece, velocity, what does it mean? Can I stitch that all together in real time, right? This is the world of big data, this is the world of data science, this is the world that creates that kind of personalized value. Because just think about this, right? Let's say Google, you typed in a search query in Google and it said it did everything, the same algorithm to try in the back end, everything, but then sent you a PowerPoint 1 week later with the results. What value does that have, right? It has zero value. The value really comes from the fact that you are able to do all of this in real time and make, that's the context between all the volume, variety, velocity. It's not what is considered what big data consists of. The purpose of that statement is that you have to be able to deal with massive scale of variety of touch points and be able to make that decision in real time. And so that's the promised land. Right? You actually can. So here is the deal, right? So let's, I want to make this fairly informal, right? How many of you are familiar with a company called Nest? Okay. Who acquired Nest? Why?
Data, big data.
Well, I know, that's not enough more. What big data? What big data does a thermostat company have that Google would be interested in?
They want to control the home devices.
No, why would they want to control the home devices?
Not.
So Nest has this ability to track the customer, whether when the people are in, when people are out, and it gives the customization.
Okay, and so what is the? I'm just
so that makes
digging deeper. So anybody can answer. I don't mean to put any one person in a spot or anything. So yeah, so
what I read about Larry Page's interview recently,
yeah.
he said that his ultimate dream of Google is like, say there's no milk in your fridge, then it sends out a signal to your Google car which goes to a store which buys the milk.
Absolutely, right? But what is the point there? Yeah, Larry Page always makes it sound like it's making your life great and that's all he cares about, right? So that's correct. But the point is, what is the point here? The point here is that's the only thing Nest and Google Glass is supposed to do. The point here is unless you're staring at a screen, Google has no idea what you're doing. They have no idea what you're doing unless you're staring at a screen. Right? The screen could be your phone, your device, your computer, whatever. Once you step out of that, they have no idea what your life is. But they want to catalog your whole life. They want to catalog every aspect of your life, right? They want to know your life better than you know your life, right? So that's their stated mission. The stated mission, if you think about it, Google's stated mission has not changed. That's the beauty of Google, is the focus. What Google said was, I want to organize this planet's information. And the information exists in the human beings, and it exists in their life, right? So the point is, how do I get offline? How do I get offline? How do I know what you're doing offline? And those are the two big plays for them. Three, Google Car, but Google Car is a little bit further away. Google Glass and Nest are exactly that. What Nest wants to do is instrument everything in your house. So as long as you're in your house, they know everything you're doing. And once you step out of the house, hopefully you're wearing your Google Glass, then they know everything you're doing. So then they know everything you're doing in front of screen, they know everything you're doing outside your house, they know everything you're doing. How did we enter in the customer care industry? It's not the place where most Silicon Valley companies end up in is because there is a set of data, what we call commercial graph, right? It is essentially where consumers are spending money, we know what happens to them after they spend the money or when they are spending the money. We know the questions they have about products. We know when they come back about the product, what are the problems they are having. We know exactly, we are building a set of sort of a commercial graph which is fairly unique to what we have, which nobody else has. So that's our value proposition. So while we are not conquering the world like Google, we have building a unique set of data elements that provides a unique set of insights about products and services where most of the people spend most of their money. That's the game, right? So what what is anticipate, simplify, and learn? This is our basic construct of what we are trying to do, right? Anticipate. What does it mean? Anticipate means can I predict a consumer's intent? That's the goal, right? First, the structure is very simple. Anticipate. Figure out what a consumer's intent is. In the example I gave you, the intent of that company, the consumer whose credit card got declined, his intent was obviously, I want to start using my credit card. It's very clear that is his intent. Simplify. Once I know that intent, there is no point in me making him say 1 for account, 2 for blah, 3 for blah, 4 for blah, and sending him to a customer care representative. The guy starts out the story all over again. What's your account number? What did you do? What do you want? Blah. Simplify is, if I know what he wants, just do what he wants. What he wants is card to be active. If he wants his card to be active, activate it, right? And learn, right? And the point is, anticipate, these are all statistical algorithms. They're not going to be correct 100% of the time. They're going to be correct some fraction of the time. It could be 50, it could be 60, it could be 80, 90, whatever it is. It doesn't matter. And the point is, if you have a good platform, it will learn and scale over time. So that's essentially the anticipate, simplify, learn framework, right? The people who buy on their own, you let them buy on their own. People who are not going to buy, let them go. But the people who are going to buy right now today, the guy is having a question, I don't know if this will last long. That's the guy you want to target and answer a bunch of questions and sell him the. Can you do that at scale statistically? Going back to the brick and mortar example, right? Can you do that at scale statistically? That's what this is doing. So basically it's trying to put so the math here is essentially trying to predict the probability, incremental probability that somebody will buy through a chat. Basically it's saying what is the probability they will buy incrementally through chat is what it's trying to do. And it's starting to sort of score people based on attributes. We tag all the web pages and then we are sort of scoring them every few seconds, right? And what you see here is the score, right? The score will keep on evolving as the journey keeps happening, right? Sometimes it may go up, sometimes it may go down. Depends on what really is happening. At some point, the score goes above a certain threshold. Whatever the threshold is, that creates incremental marginal profit, basically, economically. So then it'll pop a chat, right? And that's what a chat will look like. And the chat itself can be designed in different ways. Different way you design it, you would have different outcomes, right? And then you sort of start chatting. And this could be automated, semi-automated, or have an agent, whatever, right? So, but the point is, you have the chat. As soon as the chat is over, you're sort of mining 100% of the chats and giving real-time feedback to the agents on what worked, what did not work, what did you do in the chat, so on and so forth. And then you're giving what you call voice of the customer. So this is essentially mining all these chat interactions to figure out what they liked about the product, what they liked about the service, what they didn't like, what's working, what's not working, what's selling, what's not selling, what features do people like, what features are they asking about, all of these things. That's your current journey, right? It's a context of a prior context, right? If you came in last week to buy a sort of a formal shoe and you went back without buying, very likely that you're looking for a formal shoe once more. It's not as likely that you're probably looking for running shoes or whatever, right? Things like that. For example, you went to a store, you looked at a suit, then you didn't like it, you thought you'll check for other stores and come back. You're not going to come back and say, give me a dhoti. That's not likely. That's not a very likely scenario. It's likely that you're coming back and say, hey, show me that suit again, sort of thing, right? So prior context, okay? And I'm giving you a sales scenario, but I'll talk about service. This is across sales, service, everything. Okay? Location, right? location could be a key factor as well. Right? What you want to buy is a function of what location. If you're trying to buy a car over the web, you will not be looking for, if you're from Alaska, you're probably not looking for a convertible, right? Things like that. So, or there are much better examples than what I just gave, right? Identity. Identity is as much information about your own user profile, which is the core personalization, customization. In this case, what you saw was the data came from chat and web self-service. Yeah? So here is what we do. We extract the intent out of the chat. Right? So one of the cool things we have, which is a big differentiator for us, is we run sort of 8,000-10,000 people call center. That's a huge, there are actual human agents doing chat. What it helps us do is it helps us tag at scale. So I don't know how many of, are any of you familiar with what machine learning is or statistics of machine learning? Not technically, I don't need you kind of conceptually understand what happens. What essentially happens is, in machine learning, you basically train a model based on data where you tell it what it is. So for example, in this case, what consumers are doing, what the agents are doing, they're tagging a bunch of chats, saying, hey, this chat is about purchase intent and for a tablet. Okay? So if you do this at scale, this is called labeled data. Now the machine learning models learn from this, then it can predict into the new corpus or new data sets what the intent is based on the chat they see. So basically, if you look at it, they're looking at this chat, so there is a bunch of, maybe there are 5,000 labeled data where it says there is an actual human labeling this. This is called supervised learning. There's one technique in machine learning, which is essentially saying, I'm looking at this data and I'm saying it is about buying a tablet. And with that, I take all the buying a tablet labeled data, and from that I'm able to learn what are the features of a chat conversation that means somebody is trying to buy a tablet, right? Now I can go out and classify 100 million, 200, there's no end to scale. That's the basic benefit of machine learning. Yeah? So that's the thing. So now we are deriving intent from the chat. Once you derive intent from the chat, here is the intent from the chat, right? Now you have a historical data set where you derive intent from the chat, and then you are mapping that to the web journey. That's what a web journey looks like. That's what it looks like in the structured data set, which is, was it a search term, organic or paid search engine campaign. This is a small set, there are hundreds of variables like this, right? So now what's happening is, this historical data of people who went through a web journey and then chatted with you is used to train again a machine learning model where given a journey I can predict intent. Does that make sense? That's what you saw happen. Given a journey, I'm predicting an intent. Yeah? So here is a simple example of what that can do, right? This is just based on one dimension. The dimension is search term. Okay? And this is what you're seeing in the back end is the model doing things in maybe hundreds of dimensions like this in being able to predict intent. But here's one dimension just to show what it does, right? So here is self-service conversion, here is chat conversion. Okay? What are you trying to do? You're trying to maximize chat conversion without cannibalizing self-service. Which is, I want only to target people who have a much greater propensity to chat than through self-service. That's where I'm creating value. Otherwise, I'm just cannibalizing self-service, which is a lower cost chat. Clear, right? So now look at it, right? When search word is student or coupon, the incremental value created by chat is not much. And why is that? That's because that's the target buyer, right? Okay, it's a student, they know what they want the cheapest laptop. What are you going to help them with? As long as it's available and all the features, they're also very informed buyers. On the other hand, take a search term like ThinkPad tablet, right? Who buys a ThinkPad tablet? It's not the most common tablet, it's not the most well-known tablet, it's probably a bargain buyer trying to find out, hey, if I have a basic set of features that's enough for me, I need to know whether ThinkPad tablet has those features. That's a classic buyer who will incrementally benefit through chat. So that's an example, this is real data, right? So this is essentially the kind of data that determines what are the drivers of incremental value creation. And then this is classic analytics, right? Which is essentially saying, if I sort of rank a bunch of people based on their deciles, right, does it really match with reality? So if my model is good, then it should look like this. The steeper it is, the better my model. What it's saying is, people who scored the highest for propensity to purchase through chat in my model are indeed converting the most. Right? So the steeper it is, in this case you see a 250x between this and this, and about a 25x between this and this for the agent. Right? Here is a response time. So to drive down agent response time, I have a recommendation engine built. So it's actually real-time mining the chat and proposing to the agent what they should be saying. Right? Or you take certain issue types that are problematic, that are driving poor customer engagement. You're trying to provide sort of knowledge articles for those in the agent console. Right? Things like that, right? Essentially, these are all product features that can address each one of these. So let me go quickly to the last piece. This is the thing. This is actually pretty cutting edge. So this is going back to the IPR, natural language speech recognition and all that. So this is what you saw till now was a sales scenario for chat. Okay. Now what you're going to see is a sales scenario for speech. Just watch this, I'll tell you what.
Hi, thanks for calling Trust Bank. I see the number you're calling from and found a recent match. For security purposes, what are the last 4 digits of your social security number?
2341.
Thanks. It's great to hear back from you, Mr. Smith. How can I help you?
Nothing wrong with my name.
Sure, I can help you with that. Are you calling about the charge for $522 at JCPenney's made on Saturday, January 12th?
Yes, I am.
Got it. Let me connect you with a customer care specialist who can help you with this charge. Just a moment, please.
Okay. So here is what happened here, right? And that's essentially what.
The bottom here is basically when you are trying to avoid much interaction from the customer with remote information, maybe matching the your model such a way that it goes back to the customer rather than asking more questions to the customer.
Absolutely. Basically, I'm trying to reduce what you saw that first when I started customer effort. Our goal is to drive down the customer effort in a customer care interaction. That's all we are trying to do. At the end of the day, any customer in a sales interaction, we are trying to be there to answer the specific question the customer may have in buying a product. So again, driving down customer effort. In service, we want to drive down the effort it takes to resolve something for the consumer. That's it. That's essentially what we are trying to do. So in this case, what you're going to see is what actually happened in the back. Okay. First, there was a prediction of identity, right? Identity based on the phone number, but not just on the phone number. Multiple people can call from the same phone number. Then it used gender, it used a few other things like recency, frequency, models, and then based on it, did an identity. But then it verified the identity by just the last 4 digits of the social security number, and then it went on and predicted the intent and so on. So it said something wrong with my statement. If you just had a speech recognition system, it would be very difficult for it to disambiguate between things like something wrong with my statement, something is wrong with my statement, something is wrong with my statement, things like that, right? It's not very easy for them, for just a core speech recognition system to disambiguate these sort of very similar sounding things. So what happens is, the speech recognition system gets trained by something called a statistical language model. What that is doing is it is building context. It's building context into what it's likely to be. So what our model in this case is doing is, there is a whole lot of, and this is where our chat comes into our rescue as well, right? So the thing is, it's very difficult to sort of train a model with a lot of speech data, because speech data has to be transcribe, but to transcribe these data again you need to manually do it because the speech recognition system can't do it because that's the problem you're trying to solve in the first place, right? So we are lucky because we do chat, so we have millions of chats, right? Plus we also do a little bit of transcription, manual transcription, and train the speech recognition engine through a statistical model. So in this case, what in this case it's doing is, obviously that was Trust Bank or whatever bank that was, right? So it knows that given the history of data, that's what the statistical language model or machine learning model does. Given the history of this data, which is trained over millions of historical chats and speech utterances, it knows that it's far more probabilistic that in this context of a bank, it's likely to be something's wrong with my statement rather than any of the other things. That's essentially what it's doing. In plain simple English, it's saying that it's far more likely, given that it's a bank's data, it's this. But it's doing that at scale through automated machine learning, right? So then it knows something's wrong with my statement. Is all of that data together to make a prediction again, what it realizes is transaction dispute is far more probabilistic than billing fraud. Essentially that's what it is. Yeah? So in the interest of time, I'm going to skip through this, more of the same. But essentially the way we are, yeah.
It's not audible.
It's not audible? Okay. Is this better? Okay. Good. So in the, at the end of the day, we are a gain share company. So we measure things like, our promise to our clients are, okay, we'll drive up revenues, you give us a share of that. So we grow revenues, or it could be, the one thing we do is, we are always sure we are not cannibalizing channels that already exist. The revenue itself should be incremental. Otherwise, it's very easy for me to go to a guy and say, I'll put in my chat platform and I'll drive a lot of chat and just cannibalize self-serve revenue and drive his cost up and keep his revenue flat. So this is an experiment we are constantly doing. This is called an A/B test. Essentially saying, for the same profile that I'm targeting, if they were to go through self-service, what would be the conversion rate? That's the whole purpose of the machine learning model, right? So the purpose is to figure out what their likely prioritization is going to be. But the point you have to remember is I have to be better than the current system. The point about any machine learning system, whether it's a search query or whether it's this, it's not that it's going to be 100% accurate. The point is the user experience created has to be superior to the user experience that exists today. The point, go back to the simple example. Essentially the question you're asking is what if you're wrong? That's all you're could be multiple, whatever it is. What you're saying, what if you're wrong? It's very straightforward, right? Today, what is the experience? Always, at the end of the day, we run a business. Look at today's experience. Is my experience better than that? Take that example I gave you, the Citibank credit card. So the guy calls. Today what happens? It says, press this for account for 1, press this for 2, blah, 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 blah. Right? It goes on and on and goes through a complicated tree. Let us say, I have a 0.75 probability that my prediction is right. Let's say that's all it is. Okay? The guy calls in, like 100 guys call in. 100 guys call in today. This is the experience that all 100 guys have. Agreed? That press 1 for this, press 2 for it. So 100 guys call in that word. 75 guys have a great experience because I said, hey, is it about transaction decline? Yes. Okay. Pay your bill. Just because, boom, done. Remaining 25 guys, it's again, it's no words. Because what am I going to say? Okay, if you are calling about a transaction decline, then it's because you haven't paid your fee. And if it's not, press 1 for account information, press 2 for it. So it's the same experience for the 25% whom I mispredicted, and it's a much better experience for the 75% I predicted well. So the point I'm trying to make is, it's not just about data science. You combine, so we have just to this thing, right? My counterpart, it was another sort of one of the other persons, a chief design officer. So for us, we have invested in design and data to a level that both of these are C-level positions. The chief data scientist and the chief design sort of officer are both senior leaders in the company, because we believe these two are what create the intuitive consumer experience that that's how we are investing as an organization. For consumers, it's obvious, they will start adopting the minute you see it, right? You will start adopting this the minute you come across it, that's it. Okay, clients, that's a great point, right? So for clients, the way, that's one of the reasons, right? Obviously, adoption is not very straightforward. I'll tell you where the biggest challenges are. It has less to do with clients not seeing value and so on and so forth. It is getting rid of the legacy system. So they have a system that is in place. Let us say they have a chat platform. Now I'm coming in with a different chat platform and different business model, right? So now the question is, they have into CRM integration, this, that, blah, blah, blah. I have to provide seamless integration into all the systems that need to happen. So those are the biggest barriers. Beyond that, I don't see a big barrier for them to adopt. So the real barrier for them to adopt is the fact that there is a legacy system they have to replace.
Also about the learning of the data, right? It will take some time to learn the data.
Yeah, but if they are running a legacy system which has no intelligence, you're going to start with better intelligence than no intelligence anyway, because I have learned from other users in the vertical. So your point was very accurate. I don't need customization for this particular client's consumers. For the fact that, let's take Target and Sears, let us say, right? So the fact that I have successfully run it for Sears, I'm going to start out better than the dump system on day one with Target. Right? Because it's still a reasonably well-known model. Yeah?
So do customers often take this as too good to be true?
It's a gain share model. So if it is too good to be true, they'll fire us in whenever the gain share doesn't.
And then they have to kind of get you in, try you out.
Right. So that's where, okay, here is how we do that, right? No, that's a great point. That's a great question.
We have that sometimes, like, hey, this is like...
Yeah, here it is. This is how we get in. We are a major retailer. You run an 8-week pilot, very low risk. What we say is, we will run it in 10% of your volume, and we compete with your incumbent. And this is what we usually end up doing, because the incumbent is not usually sort of this thing. So the adoption is, that's a good point, right? And that also, so the way that we do it in a low risk fashion is, see, the one thing you need to remember is, right, web-driven solutions people are very, it's very different from most other businesses in the web world. The nice thing about the web world that Silicon Valley has created is people are willing to experiment all the time. Right? So here it's a very easy experiment for them to run. They will divert 5-10% of the traffic and say, hey, you put your platform there, see what it can do. And if I show these kind of results, they just expand it to 100%. Here is the challenge we have had, right? I can talk to you as, I don't have the ability to mix, I don't want to talk in a very philosophical terms. I can talk to you as 24/7 what are the challenges I have, right? It's not like we have any sort of bias for or against doing business in India. It's very simple. We are a very premium, high-end provider of solution. So we are expensive. So which is why what we have seen is our adoption came from markets which spend a lot of money, which have two things, a lot of scale and also a lot of spending power. But the spending power and scale is coming to India, but the mindset, right? So for example, I'll tell you, right, our revenue, take a chat, sales chat, okay? I will give you an example of what I mean, right? The sales chat, if you want your, if you use our solution, your sort of cost per agent plus license or whatever would be around 2.5 to 3x of what an Indian client will be willing to pay.
But if you're in a gain share model...
Exactly. That's the thing. That shouldn't matter. So essentially, that is what we try to sell. However, the appetite for gain share for some reason in India is very poor. But that doesn't mean we don't have Indian clients. We have a few Indian clients. But they don't... See, here is the thing, right? Here is the deal that I have seen. It is not very rational. If it's rational economics, everything you say is very clear, right? But there is a huge sort of irrationality, or at least bounded rationality, because I don't know. I won't call it irrational. There is some bounded rationality here, right? Because here is the deal that happens. I've seen in India, I've seen in some of the Asian markets. It does not happen in the US, it does not happen in Australia and Europe and UK, right? Which is, let us say you are XYZ company in Asia, somewhere, wherever, India, China, wherever, right? And I am 24/7, and you start out gain share, everything is great and so on. Suddenly you realize that I'm doing really well, and you have to shell out, you plan to shell out $2 million to me, and you ended up shelling out 11-12 million. Even though you didn't make make the incremental revenue, then the system seems to, there is some antibody in the system which seems to sort of not react very well to large outlays of cash for some reason, right? So I'm not yet, I know I haven't answered this very clearly, but the point is, that's the reality is the kind of what it costs to run these systems. It's pretty expensive, but it's a gain share. So revenue to spend is very, very healthy. So our US customers think the revenue spend is very healthy. Europe, Australia, the revenue spend. But in Asia, India, even in places like Singapore, I think they are looking for a higher revenue to spend or whatever. So adoption is slower. At the same time, we do have now, in the last year and a half, that has actually grown. So my hope and my reality, I think it's just a little bit of time lag, nothing more. Because we had the same problem in the US probably in the 2008-2009 timeframe. We are having similar problems in the 2011-2012 in India and some of the Asian markets. But I'm seeing that more and more our clientele is growing fairly fast in the Asian markets. You saw in my demo something called voice of the customer. That's essentially what you're talking about, which is we may not own all the channels and touch points, so we do that as a market intelligence and provide it back to the client.
So
Yes.
give one example.
Yes.
We learn from CS, implemented target.
Not the same data. No. So that's where absolutely. No. But every company does that. That's what McKinsey does, for example. But the point is, it doesn't mean we use the same model which was trained on CS data. What we are saying is we fundamentally know what are the key drivers of consumer sales and this thing. So we are building industry level models that are aggregated on top of that. We are not going to use the same model. We have very clear boundaries between what data to use for what consumer, customer and so on. All I'm saying is I have enough understanding. See, the fact that I have done 10 retailers this thing, I know what are the 15 most top attributes that will drive target sale on the web. That's what I mean.
So do you do this what I also see is that building this whole thing, right? Whole intelligence, the whole building blocks. It's quite a investment, capital intensive.
Yes. It's like any other startup company, right? Anybody who's built a startup will know that when I make this presentation, it sounds like things just came together, but we tried a whole bunch of different things that didn't work before we came to this point, right? I can give you a few examples. Initially, we thought that alone, like what the question you asked, right? Just take your chat, build a voice of the customer and give it back to them was a very sustainable growth business. Turned out not really, because it's not like there is so much variety in the voice of the customer, and then it's not like the voice of the customer is changing every 2 weeks, right? It's fairly consistent. And so suddenly we started charging them a good amount of money for that, and they are like pushback saying, hey, you're giving me more or less the same thing what you gave last week. Yeah, because the consumers are saying the same thing as they said last week, you haven't fixed any of those things, right? So it becomes a little bit of a challenge to do it in a service mode, right? So that's when we came upon this product line. So just to give you some history, right? 2006 when we started this, it was actually an analytics service play, this innovation labs. Then in 2009 we hired a product leader, that's when it became a product line.
So, for example, you have built the industry modes, right?
Correct.
It's an industry security mode.
Correct.
So the challenge here is basically over the time, the client experience changes because of the needs the market. So how can you make it sure that your models are mature enough to compete or maybe more to meet with the client? Because the model is already built, right?
No, that's what is machine learning, right? Machine learning is actually retraining it. It learns over, as new data emerges, it learns from the data.
Yeah, exactly. So that's why you need to put more data sets or maybe
The data is continuously pouring in. So the data it's pouring in. The models are continuously updating. It's all a moving system.